What do we do if we can't trust any of these big macro scale pieces of glassware to give us a real volume? Well, enter the Buret, our first volumetric piece of glassware that we're going to be using. Now, I'm going to lift the sash hood on this hood higher than we should be using for safety. I've got water and food coloring in these, so things should be safe enough for us. Now, a couple of highlights before we get to the Buret itself. I want to talk about the clamp. Well, that's a pretty boring start, right? Not so much. Notice the Buret clamp, and that's what the proper name for this is, Buret clamp, has a very specific structure. And I'll do the empty slot over on this side. It's got two different spots where you can pull it. It's got these rubber feet with the round pieces so that they can actually hold the Buret very well. What I frequently see people do is grab one of these two types of clamps. Now this is a very bad choice. Yeah, we can get it okay. It's got the spring so we can get a decent grip on it, and it's got an okay grip, but notice there's nothing that's going to hold it from sliding very well. Here we have 2 points of contact. Here we've got one, and it's a pretty slippery one, and these things aren't really built to be super parallel anyhow. Don't use this to hold burets. If you grab one of these, and yeah, there's a little extra clamp just like this that you can mount on the back of these, so ignore the fact this one doesn't have one. This one's great for organic reactions, or again where you have a lot of different pieces of glassware that have to fit together, because you can position it from both sides with each of the 2 thumb screws that you see, pointed with my pinky, pointed again at the cross on the other side. But these shouldn't be used for something as heavy as a Buret, and something as expensive as a Buret, and something as likely to be filled with a strong acid or a strong base as a Buret. Have you picked up the point? Don't use these clamps for a Buret. Use this kind of clamp. Now, I've already got this in. Now you can see that I've left a decent clearance between the bottom of my Buret, here we are, with no depth perception. It's a little hard to tell how far that is. Now you have some idea. So we want to adjust it until we have enough space to get our beakers in and out. When we're actually ready to do a titration, we'll probably even slide this down a little bit so that we don't have to worry about having splatters pop out of our reaction vessel. Now, I picked pink as a color to put in here just to make sure we had something we could see against our background. Most of the time you're going to have a clear volume in here. That's something worth remembering. Now, you want to make sure that you rotate it so that your numbers and your lines are facing forward. You probably want your numbers rotated just off the side a little bit, and here's why. Notice that you can see, and here I'll deliberately go off axis a little bit. You can see the front and back lines on the number. And when you get to right at the right height, they actually start to line up, like you're looking straight across it. That's how you know that you're actually going to be reading it correctly and getting a real volume. Also notice that we have decimal places fully and properly marked. Sorry, I need to get my focus in. There we are. We actually have decimal places. That means we can actually measure out to a couple of places. So notice we get 2 sig figs in our whole numbers for most of these. We get our tenths place from the explicit markings, and we can always estimate one more than our most explicit marking. So I can go to 2 decimal places. Total of 4 sig figs. Not too shabby, especially for something so macro scale. Now that said, usually what we're going to do is we're just going to fill this right up close to the top. Now, I see people spend a lot of time trying to get right there to the 0 line, trying to get dead even with it. And I start to laugh and I start to tease them. Why? Well, if you're being careful, you come down here to the tip and you make sure there's no bubbles. And here's a hint, you should always be being careful. You see that volume, that bubble right there? When I turn the stopcock and it starts dispensing, I'm going to think that I just put this amount of solution into what I'm reacting. And I didn't. All I did was replace the volume in that bubble. Meaning I've just done a garbage measurement. Better to use a garbage beaker. And that's one of the things I always recommend. If you're doing a titration, grab a beaker. Usually it's empty. Here I've just got some water with food coloring so I can continue to use it for my videos. You want to go ahead and you want to turn your stopcock to flush the bubbles loose. If it's sitting in there at the tip like this, that's very easy to do. And I'll just show you from the side. That's the angle that I've currently got it on. And that's enough that it's not dispensing. Well, it's very slowly dispensing. If you look carefully, you can see a little hanging drop right there. And that's something we need to be caring about quite a bit. Now, if I have a bubble up here at the top of the glass tubing, what I want to do is I want to make turbulent flow. So I want to toggle this so that I'm dispensing slow, fast, on, off, until all the bubbles get worked out. You're going to deliberately try to go as crazy as you can on it. And you're not going to be at zero anymore. So after spending 10 minutes getting right to the line, you're going to destroy that. And here's the thing. With a Buret, you're always doing a before and after measurement anyhow. You don't want to be at the zero mark because notice, it's going to be really hard to tell that you're right at zero because you don't know about any markings above it. You want to be below it so you can actually get your bracketing values. You can look at the line above and below and make your best estimate of that last place. Always start somewhere down here, at least in the 0 point something regime. Down here, even better. You want to just make sure you have enough volume to get through your titration. Now you're going to do a before and an after. So you want to make sure that you have this value written down and this value written down. Also notice if you're going to do a couple of them in a row and you end up dispensing about, let's say 12 milliliters. You've got 50 minus about 4. You have about 46 milliliters sitting here right now. Why refill it up to the line? Just keep going for your next titration. Write down your new value as your beginning value. Dispense. Write down your new end value. That's the right way to use a Buret. These are great time-saving devices when you use them to help save some time. If you're using it to waste your time, you're only going to be wasting your time and getting more crude results than you should. Now, when you dispense, that droplet that's hanging there at the tip, you've already marked that as dispensed. Grab a DI water bottle. I unfortunately don't have one here in the hood. If I squirt it right here on the outside, the water's going to trail down and it's going to dribble and drop into thy reaction vessel down here. And you might say, well, wait a minute though, I just added a whole bunch of water. That's going to screw everything up. Ah, but it's probably not. Down here, you probably use something to tell you exactly how much volume you had sitting in this. You're probably just using the beaker as a reaction vessel. You're just holding it there like a bowl. So you already know the exact volume that's here. What you're trying to find out is the exact concentration that's there. Here you know the exact volume that you're dispensing, and you know your exact concentration because you made your stock solution very well. So you know concentration and volume, which means you know moles. You're measuring how many moles you've dispensed. You're saying it was a 1-to-1 or whatever reaction it was. So you know the number of moles that you're reacting, and you know your initial volume. So hey, Merry Christmas, I now know molarity. At no point did adding water screw that up, because we knew the volume we added, we knew the starting concentration. All the water did was help us dispense the moles that we thought we had delivered. So that's a great trick. Spray a little bit of water on it and get it to rinse down. Also remember that you probably ended up splashing a little bit onto the sides of your beaker. Throughout your titration, you should occasionally spray the rim and down with some DI to make sure that you don't end up leaving behind some of your substance and not actually titrating it. So this is definitely a long video on what seemed like a pretty simple piece of glassware, but this is the most misused piece of glassware that I see anywhere. So I wanted us to see it in pretty good detail. Now there's one last thing that we need to be aware of on these pieces of glassware, and it's going to be something I emphasize on our next videos too. Notice the very top. Climax, US, whatever. But then it says TD, 20 degrees C. This means to deliver at 20 degrees C. So this is all calibrated for the amount of volume you're delivering to your final capture volume container. Other things will be listed as to contain. This is for to deliver. There's a big distinction to make sure that you're aware of it. Is it holding that volume, or is it dispensing that volume? TD means it's dispensing it.